Linear modeling, page 1. When you plot data on a scatter diagram, the independent variable goes on the horizontal or x-axis and the dependent variable goes on the vertical or y-axis. Correlation means that there is a relationship between the two variables. Sketch a data distribution that has positive correlation. So positive correlation means the dots in the scatter plot generally are going up. Negative correlation, on the other hand, means that the dots in general are going down. No correlation means the dots are just kind of a cloud, no trend apparent. Linear correlation means that the dots are arranged pretty much in a line. Nonlinear correlation means that the dots are arranged in some kind of trend, but looks maybe more like a curve. Okay. Sketch a linear data distribution that has a strong positive correlation. So strong positive correlation means they're really lined up well. Moderate positive correlation means that maybe not so well, but pretty well. Weak positive correlation means maybe not really aligned, but seems like there's some kind of trend maybe. Notice that all of these positive ones I drew going in general up. Strong negative correlation would be arranged in a line going down. Weak negative correlation would be going down, but maybe not quite a line. Outliers. Draw a data distribution which has an outlier in the grid to the right. Explain when an outlier should be kept and when it can be discarded. So let's draw a data distribution similar to the ones we drew above, and then we'll have one outlier. So this outlier is apparently an outlier because it's so far away from the rest of the points. When should it be kept and when should it be discarded? So let's say that you are using a data set in your IA and you do have an outlier, an apparent outlier. This outlier should only be discarded if it is a measurement error. Okay, otherwise you have to keep it. We're talking about your IA here. Causation. Give an example from your life of two quantities or variables that are correlated in which a change in one of the variables causes a change in the other variable. Maybe the first variable is the amount of time you study for an exam, and the second variable is the test grade you get on the exam. So number of hours studied, and that causes a change in score on exam. Give an example from your life of two quantities of variables that are correlated in which a change in either variables is not the cause of a change in the other variable. What if you take like the grades in two different classes for different people? So like, let's say that one person has a certain grade in math and a certain grade in English, and another person has another grade in math and another grade in English. Maybe those are correlated. Maybe the math grade and the English grade have a tendency to be both high for the same student or both low for the same student. But the math grade does not cause the English grade to be high and vice versa. Okay? Math, English grades.